Let's now focus on setting up our OpenLDAP server with TLS and SSL encryption. This will ensure confidentiality between connecting LDAP clients to the server and replication traffic between our OpenLDAP server and other LDAP servers. So we'll label this section OpenLDAP with SSL/TLS encryption. SSL and TLS are almost one and the same. SSL, when implemented, listens on TCP port 636. TLS listens on standard 389 TCP. Both use the same public and private key pair to perform encrypts and decrypts, which is why I refer to them as being roughly the same. But they are implemented slightly differently in that, again, when connecting to SSL you use one port using SSL, and when using TLS you connect to the standard port, but the client automatically issues start TLS to instantiate an encrypted session. So the features include, of course, encrypted communications, because the default LDAP communication is sent via clear text, which means we can take a look at the traffic, even authentication related traffic, and discern useful information from it across the wire. So TLS and SSL help us to secure that traffic. In addition, SSL binds by default to TCP port 636. So when using an LDAP client to connect to an OpenLDAP server running SSL, the client will connect to TCP 636. This is here really for legacy support and is referenced generally with a URI of LDAP secure followed by the host name, such as linuxcbt susa2.linuxcbt.internal, whereas TLS, which also requires the same public key private key pair used by SSL, uses the default TCP port 389, which will help you if you are publishing OpenLDAP across firewalls. Then you or your firewall administrator will have one fewer port to open as a result of using TLS over SSL for encrypted communications, because again, TLS takes place over the standard TCP port 389, where it issues a start TLS command, and this is all invoked by selecting or indicating the right option on the command line. In the case of TLS, it's $Z to cause the client to attempt a start TLS session with the server. And this means that the URI is the standard URI, which is, instead of LDAP-S, is simply LDAP followed by hostname, such as linuxcbt susa2.linuxcbt.internal. So again, it's all about encrypted communications, and since this is the security section of OpenLDAP LinuxCBT edition, we want to focus on ways you can tighten up the security of your OpenLDAP server. Now, what we're telling you here also applies to other LDAP servers. Of course, we're focusing on OpenLDAP, but by and large, even Microsoft's Active Directory binds to TCP port 636 as well as 389 to implement secure or SSL and clear text communications by default. So this isn't specific to OpenLDAP. So with that said, let's get an ethereal session going that will allow us to see what happens when we authenticate using standard clear text communication. So our first task will be to launch an ethereal session. Ethereal, which is a utility that allows you to sniff as well as process sniffed traffic, is available on most Linux systems and runs on most Linux and Unix and even Windows systems. It's installed by default, and if it isn't installed, then of course use your install manager to install it. We can use it in conjunction with TCP dump to pick up the traffic that's of interest. So let's just note, launch an ethereal session in conjunction with TCP dump. Or we could use Ethereal alone. Ethereal has a packet sniffer built in. TCP dump is a packet sniffer. TCP dump formatted packet sniffs can be processed and displayed graphically by Ethereal. So on our remote system, let's determine whether or not we have it installed on the SUSE 2 box. We'll clear screen here and get a session going. Let's find SSH in our history. And once all, RPM query all grep for Ethereal. And this will search a database. If it's not installed, we'll use YAST to get it going momentarily. It doesn't appear to be. If we try to tab it out, nothing. However, TCP dump, that's RPM query all, TCP dump, should be installed, and it is. So we can use TCP dump to set up our sniff session, and we'll do exactly that. So let's define this subtask as TCP dump, verbose option. We should determine which interface will accept the traffic. So let's execute an ifconfig, and here we see the default interface, the default routable interface, which is the interface we'll use to connect to the remote server to initiate an LDAP session is ETH0, so we'll indicate ETH0. We'll also write the results to a TCP dump compliant file using the -w option. We'll call it LDAP dump.1. And we should also use Berkeley packet filters to focus in on or zero in on the packets that are of interest. If you execute TCP dump in this fashion, it will sniff all traffic to and from the host on the ETH0 interface. However, if we use BPFs, and this is where we indicate BPFs, we can zero in on or filter the traffic that's of interest. A simple port 389 will do. We could be more specific in the qualifier by indicating TCP port, but port 389 will suffice. So we want to initiate this session over on the remote system. The reason being, we will connect from our portal system, that's the Linux CBT SUSE 1 box, this box, to the remote system across the wire through the Catalyst switch, and TCP dump will be awaiting our port 389 authentication. So let's get that session going. And it's listening, waiting, and so far it has received 0 bytes, 0 traffic, 0 packets. However, if we source traffic using any of the LDAP utilities against the remote system, then TCP dump should pick up and write to the file the traffic. Let's SUN locally. Or just history grep LDAP search. If it's in our history locally, it's not, so we should try to SUN. Let's try it again. And a history grep LDAP search. We'll pick one. Here is one which will search the base DN, but we need to change the host from localhost to the remote host. SUSE 2. The short name should suffice. This will attempt to search the base as anonymous. There you see it dumps only the objects that it's permitted to. And from our last configuration where we initiated our ACLs, we see that only the objects within the hosts, or in this case the services OU, were returned. Now let's take a look at the sniff window and see that TCP dump has picked up 261 packets. These packets we can process in Ethereal. Let's kill the session of TCP dump, and now we've got a file, LDAP dump.1. It's only 27,000 bytes. With Ethereal, we can now graphically display the contents of this file. So let's copy Ethereal locally, or copy the file locally and use Ethereal locally. Let's do a which Ethereal, and it's in our path. So we will SCP from the remote system's root home directory Linux CBT SUSE 2 colon LDAP dump, and the exact file name is .1, to our current directory. And once we've authenticated, the file will be copied locally. So now we may use Ethereal to open LDAP dump. And by the way, a file against LDAP dump will reveal that indeed it's TCP dump compliant, which means any packet processor such as Ethereal will be able to open the file. Let's launch Ethereal with LDAP dump.1, and this will pop up, or attempt to pop up. Now it throws an error because the X session is unable to write to our local screen. So what we should do is launch Ethereal as the user who has rights to write to the screen. That user is LinuxCBT. And this will have the rights to write to the screen. So here we see the entire track that the packets took. Let's maximize it from the first packet up top to the last packet, packet 261, which is what TCP dump reflected. To see any useful information, follow any of the streams. Pick a stream and click on Follow TCP Stream, where it attempts to reconstruct everything for you. The very fact that you see object class, supported control, and clear text tells you that you're seeing the comms between the client and the server in a clear text fashion, which is not good. But to be more concrete, if we attempt to capture an authentication request, you'll see even more disturbing information. So, for example, on the remote system, let's launch TCP dump again, and then from our local system, we will attempt to search the remote system again using LDAP search. This time we'll authenticate as a user, and in fact we can authenticate as the root DN if we'd like. So let's copy from our history this instance of LDAP search, but we will indicate the bind DN by using the upper D option and set it to manager DC Linux CBT and the full suffix of DC equals internal. This will authenticate and make the requests an authenticated users base request, albeit the root user. Here we didn't indicate the -W option for password. Let's tack that on to have it prompt us. And now we see all of the items, and our sniff window should reveal that it captured a number of packets. In this case, 1285 packets. So let's kill it and recopy the file locally in the Ethereal window. So we'll close the instance of Ethereal, then SCP, the same string as before, but before we were logged in as root, so we'll do it as the user Linux CBT. It will prompt us, and providing we know the password, we'll have the file momentarily, and we do need to indicate root. Now we've attempted to copy the file again. Let's try that again. And the existing version of the file doesn't work, so because of the permission. So let's call it LDAP dump.2. Now it works, and we'll Ethereal LDAP dump 2. So we'll bring this up momentarily, and it loads all of the records, and we can start from the first packet and follow the TCP stream. Again, we see object class, and if we kill this and scroll through, we will see where the bind request took place. Let's scroll down perhaps to where the bind request takes place. Here's a search request. We could follow this stream, and it doesn't return much useful. Let's go down perhaps deeper into the stream of activities. Packet 40 has a bind request. Let's follow this stream. And this stream contains a lot of information. Here's what we indicated on the command line: cn equals manager, dc equals Linux CBT internal, and all sorts of other information. Now again, this is all in the clear, and if you spend enough time, for example, in here somewhere is our password. It's crypted, but if one were to spend enough time searching through the various streams just in that small packet capture, one would find easily the credentials. And again, using encryption does away with this concern. So with that said, let's set up our next task. Again, it's usually straightforward when using clear text protocols that the information is in the clear across the wire. So step B of task number 1 was to use Ethereal or Wireshark to parse TCP dump capture. Step 2 is to enable SSL/TLS encryption on the primary server, at least the primary server. To do so, we need to generate a key pair. So the first step is to generate a key pair using OpenSSL. So you need to have OpenSSL installed. Note, ensure that OpenSSL package is installed so that you can use the tool to generate the key pair. To generate the pair, we'll use OpenSSL and we'll include the command between single quotes. And we are requiring a new key of type RSA. We'll make it 1024 bits. It's an X509 certificate. We'll set nodes so that we're not prompted for a password to use the key. And we'll send it out to LDAP pubkey.pem. This will be our public key, or the public digital certificate. And the secret key is indicated by the keyout directive, which will be sent to LDAP private key.pem, and will allow the key to last for 365 days or 1 year, which is standard. So this OpenSSL command will generate the key pairs or key pair that we need. Many distributions ship with Perl scripts such as ca.pl to help you generate key pairs, but whether or not the distro includes a PL script, if you have OpenSSL installed, you'll be able to generate the requisite key pair into any directory that you'd like, and then begin the process of securing your OpenLDAP server. Now, it makes sense for us to store these certificates where OpenLDAP can read it. So on the primary server, that's this box, in OpenLDAP, we'll create the keys. And this will prompt us for some answers, some responses regarding the country, the province, the locality, etc. We'll call this development. And the common name. Now the common name is important. It should be the fully qualified domain name of your OpenLDAP server. So note, when generating X509 certificate key pair, it's also a key pair, it's a private key and public key pair, ensure that the common name or CN attribute of the certificate reflects the FQDN or fully qualified domain name of the target OpenLDAP server. So for our primary server, that'll be Linux CBT SUSE2.linuxcbt.internal, not the rootdn or any of the LDAP names in the hierarchy. And we'll define a generic email address. And if all went well, the exit status should be 0, and it is, and we should see our LDAP files. And there they are, LDAP pub key, LDAP private key. These two keys form a pair. One is used to encrypt information, that's the public key. Others use the public key to encrypt information to the server. And that encrypted communications is decrypted by the OpenLDAP server with the assistance of the private key. The private key is also used for signing others' public keys in the case where you manage a keyring using GPG or OpenPGP or even commercial PGPs. So now we've got our key pair. We need to, however, configure slapd.conf. So the next step is to configure slapd.conf to initiate TLS/SSL communications. The configuration requires at least that we reference the public key file as well as the private key file. Those are at least the directives that are required. So we will need to indicate in slapd.conf the following: TLS, and again, no need to memorize the directives. You can either reference this text file or man slapd.conf to see how the directive is to be indicated, but basically you reference the certificate file that we just created, and that is the full path, of course, etc openldap, and that'll be LDAP, and let's copy it directly from the shell so that we don't miss any characters. This is the certificate file. The certificate file is the public key of the private key public key pair. We also need to reference the TLS certificate key file. That's the private key. And it shares a similar name or similar path, but instead of LDAP_pub key, it's LDAP_private key. Again, to be safe, we'll copy and paste the name in. So we need at least these two references. Now, there are other TLS related references, such as which directory to use to find certificates, where to find the certificate authority hierarchy file of CAs that are to be trusted, and many other directives. But for basic communications, you need to indicate a public key and a private key. The rest is optional depending on how tight your configuration is. Let's modify on the primary server slapd.conf, and somewhere towards the bottom, perhaps in the DB section or below the DB section, we'll reference, and we'll just comment it as SSL/TLS configuration. Now again, both TLS and SSL go hand in hand because they both rely upon the same key pair. They're just implemented slightly differently. SSL being implemented as a bind of slapd to port 636, and TLS being implemented as a method that's called upon invocation over the default port TCP 389. So let's save the changes. We've updated slapd.conf. Now, to start the server with SSL, we do need to make a configuration change to the startup file that's referenced within the SUSE environment. So C on SUSE Linux update etc sysconfig openldap. This is where the differences or the nuances are realized across Linux and Unix distributions. The settings tend to be the same, but they tend to be distributed in slightly differently named files. So we need to update this file to tell it to start the secure server. That's the SSL server. And there's a directive in there that we'll set to yes called openldap_start_LDAPS equals yes. So let's navigate to that directory. We'll just copy and paste the directory into memory so we can change into it quickly. And that's sysconfig. We should have just nanoed it. So let's nano the full path. And here towards the top of the startup file, which is SUSE Linux specific, we see that it includes a description regarding its usage, and it tells you that when you use it, be sure to reference both the TLS certificate file and the TLS certificate key file directives. So with that said, open_start_LDAP-S needs to be set to yes. This is what will start the server in SSL mode on a SUSE box. The directive is named differently on or within Red Hat Linux, and with Solaris we simply start the server with LDAP, the URI LDAP-S : and 3 forward slashes. So set that to yes. Set open_LDAP_start_LDAP-S equals yes. And then we can restart the server. And once the server has been restarted, we can then test TLS communication. So with that said, let's save the changes. We'll rcldap restart. If all goes well, we should see a green when the server starts, and then we'll echo the exit status to confirm that it's 0. We should also be able to confirm using netstat. So confirm SSL and TLS connectivity. One way to do it is to use netstat ntlp grep, and let's paste this. And that's the slap process, not LDAP. And let's just update our notes, grep slap. And what we see is the following. OpenLDAP is bound to both IP version 4 and IP version 6 addresses, any IPv6 addresses associated, and any IP version 4 addresses associated with this box. We know that because whenever we see the 4 octets followed by a colon and a port, that indicates IPv4. But when we see 3 colons followed by a given port, then that indicates IPv6 for all IPv6 addresses. It's bound to 389 as well as 636. So that tells us it's listening to both ports. It means that it's ready to accept encrypted connections on port 636 as well as 389. So that's one way to confirm, that's that. And of course we have our utilities that we can use, LDAP search being the simplest utility of them all. So a simple LDAP search, but LDAP search for an SSL test would resemble the following: LDAP-S : and the host name, which in this case is linuxcbt SUSE2 linuxcbt.internal, or the short name if your name resolution is set up properly. So let's find an LDAP search in our history somewhere, perhaps on our local host, or even on remote host. Either or will do. But since we want to illustrate this across the wire, here's a recent instance of LDAP search. We'll turn on the -H option, the upper H that is, which indicates a URI as opposed to a host name. This will cause the search to occur against a remote system. It will also be an authenticated search, so let's indicate -W to prompt us for a password. And that has performed an SSL search. Now it's hard to tell. You can't tell by casually looking. While the search is executing, you could execute a netstat AMP to see what ports are bound, or perhaps an ANTP to see what TCP ports are bound, and you could search for outbound connections. If you're quick enough, you might catch something to 636, but the connections are usually torn down rather quickly. However, one way to tell for sure is to run a TCP dump on the target server. So let's get a history going here. TCP dump, and there we see instance 880. Let's launch 880. We don't even need to analyze the file. Let's launch or relaunch the LDAP search again. on the local system, Linux CBT SUSE 1. This prompts us for a password. This is all taking place on 636. Now, while this runs, return to the other host that's running TCP dump, and notice that the packets are minimal, 14 packets as opposed to 261 or beyond. So this search didn't do anything particular on TCP 389 that would reveal any information. Now let's kill it to see exactly what did show up. Let's copy the file back to our local system. We'll SCP it here as LDAP dump 3. Then we'll ethereal LDAP dump 3. This will bring it up momentarily and reveal the various packets. We can start from the top and attempt to trace through any of the packets. And this particular search, at any point, let's follow the stream, will return encrypted comms. Let's follow TCP stream. And this is not the actual search, this is a different search. And those searches are related to sync REPL, so in this bulk of data we can't really tell. We perhaps should have searched on 6 or scanned on 636. So let's try it again, because we do have the sync REPL process still in place, and it's picking up clear text replication attempts. So let's listen to 636 and then try the search again. This will give us much more useful information as opposed to the sync REPL sessions that are ensuing. Now we see we've got roughly 2,000 packets, just under, and the search has completed. Now we can kill this. It's been saved to LDAP dump 1. We'll copy it over as LDAP dump 4 after killing this ethereal session. And now we've got LDAP dump 4, and we can open this file, and everything in here is now encrypted. Now how about testing TLS? Now TLS testing is as follows. A similar LDAP search, but we turn on the upper Z option, or if we insist that TLS connectivity go through, we indicate 2 Z's, so 1 or 2 Z's, followed by the upper H option and a clear text URI, which means simply LDAP as opposed to LDAP secure, or just the host name. This initiates the start TLS method. Let's try it. We'll take the -Z option and tack it on to our LDAP search. Let's find an instance here. This should be good. And we'll change this -H referencing LDAP secure to include -Z. And this performs a TLS outbound connection on port 389. And again, if we're quick enough, we might see some traces on port 389, but again, has to be quick enough, otherwise we'd have to sniff for it. And a packet sniffer would tell us, of course. Let's sniff on 389. And currently it's got some packets. Again, sync REPL is running, so we should expect the packet count to jump here and there. So it's currently at 14. Let's try that search again. Now before we press enter on the password, it's now at 27. Now we'll go ahead and it's going to fly. And there it is. So those are TLS related packets because we've used -Z. Now if we again want to insist that TLS connectivity goes through, we use 2 Z's. This will fail if TLS connectivity fails. And again, no need to memorize, just check the help, the man page, and you'll see. So let's indicate that one way to run it is as follows, and yet another way to run it is as follows, with 2 Z's. But again, using Z, double Z's, or LDAP-S as a URI all require that you have generated your public key private key pair for use with TLS and SSL. The real advantage, although albeit at some trade-off to speed to performance, is that your connectivity will be encrypted. Your connections between the various LDAP clients, LDAP add, modify, mod RDN, so on and so forth, search, will be encrypted when you elect to use either SSL or TLS. Setting it up is not difficult, and it will definitely protect your data in transit. Configuring TLS and SSL on the other hosts is also done in a similar fashion. You use OpenSSL to generate the key pair. You modify the slapd.conf to reference the key pair, and then restart the server and connect to it. Now again, changes on one server do not impact another server. So if we try to search a remote system using TLS, for example, let's try serve4. It tells us that start_TLS, this is the first we have witnessed an error running this, has failed. It's unsupported on the remote system. We can also try Sun1. And the Sun1 box appears to have TLS set up. Perhaps during testing we have configured it. And the double Z's confirm that it's running on the Sun box but not on the local system. Now in the remote system, the Sun box, let's try to kill the running instance of slapd. We'll history grep kill and find the instance that contains cat. 503 will do the trick. Now that the process has been killed, let's try to execute that LDAP search again. And of course it fails. Start TLS cannot start. Now let's restart the server. We'll use instance 493 in the history list. This will start the server. It's running, and then we'll try again. And now it doesn't support it. So we had removed the TLS session or TLS certificate directives prior to recording, but the service was still running with the certificates in memory, which is why it accepted the TLS connection. And now no longer supports the TLS connection. And what it does is it falls back on the plain clear text connection when it's unable to perform TLS. And if we tried, for example, with a URI of LDAP secure without the Z option, this will attempt to connect to 636. And it doesn't work because we didn't start the remote server with 636. Now regarding making the change necessary to the Red Hat server to support TLS and SSL, let's just note that in this section as a separate task, and that is to configure Red Hat system with SSL/TLS. As mentioned, we need to generate an OpenSSL key pair. So if we take the work that we've done on this host thus far and just reuse it, let's history grep OpenSSL. We'll use the same OpenSSL command. It works on a variety of systems so long as you're using the open source version of OpenSSL. And over on the Red Hat box, let's find that window. Here it is. We'll navigate into the same directory, open LDAP, and execute it just the same way. indicate the same codes we specified. And development, we'll just fill out the certificate information. Of course, the CN changes here to Linux CBT Serve 4. This is important. The TLS connection will fail if the CN is incorrect, or it will throw an error if it's incorrect when the LDAP client attempts to connect. And let's check this email address. Now the certificates are in place in etc open LDAP. We can copy the directives verbatim from the host server. So let's grep TLS from slapd.conf and extract the settings verbatim, since the paths are identical. They'll slightly change on the Sunbox, but that's fine. And we'll modify slapd.conf and place it towards the bottom of the file. And there we see the sync REPL replication that's there every 3 seconds, which creates the packet traffic we saw, which we could update, by the way. So once TLS and or SSL is in place, we can update this sync REPL process to use LDAP Secure or Start TLS. So now we've referenced the TLS certificate file and key files. Let's save the changes and restart the service. But before we restart it, we want to turn on LDAP Secure. So step 1, generate SSL/TLS key pair. Step 2, update slapd.conf. Step C, update. In this case, it's in etc sysconfig, and instead of open LDAP, it's a file named LDAP. In this file, we will place the directive slapd_LDAP secure equals yes. This is the directive that's required in the file. Now, on a Red Hat system, this file may not exist. If it doesn't, create it and place the lone directive. So let's go ahead and do exactly that. We'll nano etc sysconfig. If it exists, nano will open it. If it doesn't, it'll be a blank buffer, and it doesn't, so we'll just paste the directive in, and the next time we restart LDAP, it will listen to port 636, providing the LDAP service is able to find, that slapd is able to find the certificate key pair. Now let's restart the service. Service LDAP restart. This will restart LDAP, and hopefully it starts up cleanly, and it does. Which means if we netstat ANT for TCP/IP grep slap, we should see that it's bound to 636 and 389 for IP versions 4 and 6. Which also means we can perform TLS searches against it. Let's find our window where we had TLS searches in place. Here is one. This is a TLS search because it references ZZ. It prompts us. It doesn't return a start TLS failure, as we saw earlier, and now it returns the dataset. Now again, there is performance overhead or a performance hit whenever you use encryption. That should go with, or be without saying. That should be implied. But at least we are able to take advantage of encryption, which is the whole key here. So this server is up, and let's try to connect to it using LDAP Secure or 636. Now, you may be wondering what happens if you try to join SSL with TLS. Well, this doesn't make sense. So it tells you that it's already started. In other words, the LDAP search command parsed upper ZZ first and realized that we attempted to initiate or intended to initiate TLS. So as opposed to attempting to start both, it starts one, not the other. So it's one or the other. If you want to use SSL, disable TLS. If you want to use TLS, disable SSL. This is using SSL, and it returns the results, and it does so on port 636 on the remote system, and there it's returning them to our screen. So now this system is set up for TLS connectivity. Now generally speaking, you don't set up LDAP on 636 alone. The ideal way to configure it is for both clear text and and TLS support on port TCP 389, and limit connectivity using ACLs, credentials, as well as TLS. Encourage your users to use TLS, but you could force it to if you had some sort of strict requirement. If you man slapd.conf, you'll see how you can force the daemon to only accept TLS connections or only bind to port 636. For example, if you start the server, like on this Red Hat box, if we psef grep, you'll see how the service is called, which helps us out on the Sun side. When you start the server, you basically make URI calls or prefix calls using the -h option to the cleartext and secure protocols. So if you want only secure SSL LDAP server support, you start the service and reference LDAP s : followed by 3// as opposed to LDAP without any s and LDAP with an s. So you can tell the server to bind itself to 636 and not 389, but it's generally not advised because most LDAP clients are configured to query port 389. Of course, it means you'll have to adjust your clients if that's what your security dictates. Now, as mentioned, OpenSSL works similarly on all distros. So if we copy the OpenSSL command, let's find it somewhere in our notes. There it is. And on the Sun side, which we have as a separate window somewhere here open, there it is. If we navigate, and we are in the etc OpenLDAP directory, so if we execute this command, providing OpenSSL is in our path, and it is, it'll execute, and it defaults to US, so we'll go with US. We'll indicate the state, as we've done, the city, the organization name, and so on. Common name, in this case, it's Linux CBT Sun1, Linux CBT .internal, and the email address, we'll set it to support. So now we've got the LDAP files available, private and public, and of course we need to update ldap.conf, for which we can just take the directives that we've copied from the master or primary host to the Red Hat box, now over to the Sun box. Let's nano slapd.conf, navigate towards the bottom, an empty space. This also has sync REPL set up from earlier. It's been replicating since. As you can see, some of the records have doubled up. We may need to clear the records out from one or more of our OUs, or just double check, maybe because of all the protocols, it truly is just under 5,000 records. This path needs to be updated to be user local etc. And now we can attempt to restart LDAP. Let's psef grep LDAP, and it's actually slap, and it is running, so we will kill it, and then history grep and try to restart it. Let's use instance 512. Now 512 will start without binding to 636, which is fine, but it will support TLS, which is also fine. So now when we psef grep slap, we see that it's running, and a netstat will show that it's also listening. A netstat n grep slap, or just a netstat n t dump, and it's somewhere there in the history, but it is up and running, listening to port 389 at least. Let's go ahead and, before we wrap this up, execute a search against the Sun box by changing the host name to Sun1 and changing the URI to simply LDAP and setting the option to ZZ. Now, if start TLS were to fail, we would have seen it before the prompt for the password. So the fact that we got the prompt with a force of start TLS tells us that the server supports start TLS. And of course, if we wanted SSL support, we would start the server having it bind to port 636. So with all that said, the process of securing your server is straightforward. Generate a public key private key pair, reference it in the appropriate slapd.conf, start your server with an optional LDAP secure or rely upon start TLS, and your communications will be encrypted. You can always confirm your communications are encrypted by using a sniffer like TCP-dump or Ethereal. And once this is in place, in conjunction with some ACLs, you have considerably tightened the security of your OpenLDAP server.